Good morning, everyone. Welcome to this DVB Demos 2021 edition, and thanks for joining us. If you're with us now, if you're live, then please share this video with your networks because, of course, for you, it's much better when it's live, right? Anything could happen, and also for us, we'd love to see you in numbers. Of course, this event will be also recorded, so you'll have a chance to see it as many times as you want. And I'm quite sure that some of the world's first demos that you'll see today are worth at least a second look. But another very good reason to watch live also is that this afternoon and today only, you'll have the opportunity to meet some of the companies that you've seen and interact directly with them to see some more about their demos. And for this, you need to book meetings with them. So to do so, simply go on dvb.is.me, choose a slot with the company you'd like to see, and then just connect this afternoon with the link you'll have received. But before we start, I turn to my colleague, our chairman, Peter McAvock, who is waiting in the studio.
Morning,
Hi,
Emily.
Peter. Good morning. So you're with us today in Geneva. What would you like to tell us before kickoff?
Thank you very much. Well, the first thing I'd like to say is I wish you all the very best of luck. Having seen a preview of what's on show, it promises to be very interesting indeed. I think it's a great testimony to the resilience and the innovation within the DVB project that we have so many interesting interoperable demos here on display today. And the concept is lovely of having a quick snapshot of all the demos in the morning, and then your ability to book meetings in the afternoon with each one of the individual demonstrators, so as to investigate much more in detail. So I remind you, don't forget to book your meetings, but please just hang around for this great show, because what we've seen is that the DVB project has come a long way. I mean, we've been around for a very long time, but the challenges that we face are new and very relevant. It's all about trying to ensure that we prepare for the internet-centric broadband distribution of the future. And of course, we're building upon our pedigree of being the cornerstone of broadcast television for the last nearly 30 years. We know that with that experience, with all the stakeholders involved in the DVB project, we have a unique opportunity to try and develop the interoperable high quality standards that are needed for the purposes of securing an economic and a viable future in this OTT and live broadband distribution market. So if we look at the way the DVB has evolved over time, it has come from broadcast through hybrid, and it is now preparing for an all broadband future. The aim here is to build upon this pedigree, as I mentioned, and to pick state-of-the-art technologies. Some of the major work that's going on at the moment is in next generation video codecs, which we hope to have some good news on shortly. But that's just one aspect of a whole ecosystem, which you will see on demonstration today. So with that, I would urge you, hang around for this whistle-stop tour, book your meetings, and with that, I wish all of the participants the very best of luck. We would love to see you during the course of the day. With that, Emily, I pass back to you.
Thank you very much, Peter, and that's a great opening. Indeed, people are tuned to hear about the future of TV, and the stakes are high for this future. It will really depend on the steps that will be taken in the next couple of years, and that's our members' focus. So today you see 10 demonstrations from 15 members, because some of them have collaborated together to achieve some end-to-end demos that they will outline each from their own angles, which is promising to be very interesting. So those 10 demos are simply kind of previews of the future of TV, and you'll see that DVB-I is central, even if sometimes it's in the background because the focus can be on other aspects, for instance, on the delivery with DVB-Dash or DVB-MABR. You'll see also in the spotlights today DVB's new native IP solution, which was using all of those pieces. And also we'll be also talking about 5G, simply because it's one of the possible delivery networks for any DVB-I services, or I should say any future TV services. So don't forget to book your meetings as we move along by simply picking your slots on dvb.is.me. And now, without any further delay, it's time to look at this future. So I'm delighted to welcome our very first participants. So Nicolas Frame from TPV Technology is with us from Belgium. Good morning, Nicolas. We are all eager to hear from you now. So I'll be back at the end of your speech.
Great, thank you, Emily. So good morning to everybody. Welcome. Thank you for joining us. So we'll start the demo event with this first demo on focusing on DVB-I, one of the main advantages of DVB-I, which is its ability to deliver a set of services to a maximum number of devices, so maximizing the reach, whilst also delivering optimal quality to each of the devices based on its capabilities. So to look into this more detail, we have the following 3 devices in our setup. We have a mid-range 4G Android smartphone, we have an HD TV, and a UHD TV that supports the latest features and formats. So all these 3 devices are connected to the internet and have installed the same DVB-I service list. So they're receiving the same 2 services in this list. Channel 2 is a low latency dash service kindly provided by Broadpeak for these demos. That's there mainly to demonstrate channel change. Our main focus is the first service there, channel 1. So this is delivered in multiple different ways. Using what we call DVB-I service instances. And each instance is a combination of a delivery method and a particular format. And they are prioritized, which means that a DVB-I client knows which one it should try to play first. So here we have 3 different instances for channel 1. The highest priority is a dash-delivered UHD HDR instance with AC4 next generation audio. Next, we have a broadcast DVB-T2 delivered service instance with HD video and Dolby Digital Plus audio. And last but not least, a dash-delivered AVC video with AAC audio. So we'll be going to look at how each of the devices behaves when we select channel 1, and we'll talk you through that in more detail. So now let's start with the first device. So the smartphone. As you can see, at the top right there, you can see that it's got the 2 channels installed from the service list. It's running the DVB-I reference client, the web application version. And so if we select channel 1, you'll see the content of channel 1, so as expected. As a user, this is very simple. Under the hood, what's happening here is this is not a UHD device, so it has skipped that first service instance. It does not receive or support T2 broadcast, so it's also skipped the second instance and has chosen the third, which is what you see now. So that's all hidden to the user, very simple user experience. Of course, in the future, phones will be able to support broadcast through 5G, which is also something DVB is working on, particularly in the context of DVB-I. Moving on to the next device, we have the HD TV. Now, this is running the HBBTV variant of the DVB-I reference client. Again, the same service list is installed, even though the UI is slightly different. And if we tune to channel 1, you again see the same content as you'd expect. In this case, it's not a UHD device, so again, that first priority service instance has been skipped, but it does support T2 and it's receiving that broadcast, and so has selected that second instance, HD HEVC and Dolby Digital Plus. This also shows how easy it is to integrate existing broadcast services into a DVB-I service offering. And so last but not least is the third device in our group of devices, the UHD TV. So this one is a production Philips OLED with a prototype software with native DVB-I support. So you see the hybrid channel list is installed there, and if we switch to channel 1, you'll see that it's showing the UHD HDR, so that highest quality service instance, so the UHD HDR with AC4 next-gen audio, because this device supports that feature. So you'll see that all 3 devices were able to offer the service. From a user perspective, very simple, it's a matter of tuning, switching to the channel. But of course, and each device was also able to offer the best quality it was capable of, because of those the available service instances. So DVB-I has maximized the interoperability, but also the quality. In addition to that, because we've combined delivery methods, broadcast and broadband, we're also able to make it more resilient. Indeed, if broadcast or broadband becomes unavailable, so in this case of this TV, for example, if the broadband signal was to become unavailable, it would be able to fall back to from the DVB-UHD instance to the DVB-T2 broadcast instance. And that is what you've just seen happen. So in conclusion, to sum up, DVB-I allows us to build on existing deployments. So build on existing broadcast services and OTT dash streams are already available and in use today. It can help us reach more devices by being able to offer the formats that are interoperable with the highest number of devices, whilst also enabling us to optimize the quality by offering higher quality formats that the latest devices can take full advantage of. And finally, it can also help with service resilience by combining broadcast and broadband delivery methods. So thanks very much for your attention, and I do hope you enjoy the rest of today's demos.
Thank you very much, Nicolas. That was really enlightening. But in the end, is DVB-I a revolution or an evolution when it comes to future TV delivery?
That's a really good question. It may seem like a revolution, but it's actually more of an evolution because it's just combining existing technical building blocks, existing features that are in use today, but it's just bringing them together with new signaling. And that combination, as we've just shown, is really more than the sum of its parts. It really enables really interesting new use cases all the time while preserving that very simple TV experience for the end user.
Okay, so it is intended indeed to be a revolution, but for the time being, I can say yes, it can be used as a powerful tool for this migration also to IP. Thank you very much, Nicolas. So now let's have a look at our next demonstration, which has been prepared actually by 5 different organizations, of which 4 DVB members. So this consortium will be represented today by Thibaut Biatek from ATEM in France. Welcome, Thibaut, and the floor is yours.
Hello, everyone, and thanks, Emily, for the kind introduction. Before talking about our afternoon demos, I would like to quickly introduce the Nested project. Nested is standing for New Video Standards for Enhanced Delivery. Nested is a 2-year collaborative project funded by the Brittany region, putting together ATEM, NNSys, IETR, Orange, and VIO. The goal of the project is actually to develop an end-to-end delivery solution for linear TV with a focus on 3 key aspects. First, the sustainability and energy impact of the end-to-end transmission chain. Second, the quality of experience of the delivered video services for the end user. And finally, the optimization of architecture and delivery network in order to further reduce the cost for operators. And in order to do so, the project is leveraging some technologies developed by 3GPP, DVB, and MPEG. Now let's have a look on the nested use case. In that slide, the situation of an operator like Orange is represented. From the left side, the origination of the content, to the right side, the devices within the middle, the headend, and the delivery network. First observation on that situation is that the variety of devices that shall be addressed today is quite huge. It could be traditional TV, smartphone, tablets, laptop, and set-top boxes. Second, such operators shall deliver video services over various networks in a quality consistent manner. For instance, IPTV, mobile network, and even over OTT. And this architecture has actually several drawbacks. It is highly redundant since a single TV service is produced several times in different flavors for the same expected experience, and multiple headends producing similar video streams and are in the architecture. And at the end, it has a non-negligible cost for operators. The nested solution is addressing these drawbacks by proposing a new architecture leveraging several DVB technologies in order to remove redundancies. optimize the network and deliver a quality consistent experience, whatever the network and the device capabilities. In a first step, DVB-I is used to provide a universal service access, whatever the network and device. In a second step, the network is optimized by removing unicasting as much as possible using DVB MIBR. Finally, the coding efficiency is increased by leveraging DVB AVC using HEVC and VVC. Our selected packaging technology CMAF delivers DVB compliant streams compatible with all the devices. At the end, the multiple headends are now merged in a single one. In nested, the headend is provided by ATEM, enabling live HEVC, VVC encoding, CMAF packaging, and low latency origin server. On the network side, Enhancement is providing the DVB MIBR multicast server and client, as well as the mobile broadcast infrastructure. The IETR provides the open VVC decoding library that is used to demonstrate real-time VVC decoding on mobile processors. The media player and DVB-I client is provided by the accessor. And finally, these components are demonstrated within the Orange video delivery architecture. All put together, this end-to-end commercial solution provides a network and device agnostic manner of delivering high-quality live video services to the viewer. Now let's have a look on the demonstration we will have this afternoon. The demonstration highlights how TV services can be delivered to various kinds of devices over IPTV and mobile network in a straightforward manner. Here, we encode two live TV channels in the same time, producing both VVC and HEVC version of those services. These services are encoded in a low latency manner and pushed to the origin. Besides, some nested service lists are created and registered into a service list entry point hosted in the cloud. The different flavors of the services are described onto DVB-I, which enable access to services for devices over OTT, IPTV, and mobile. The demonstration highlights how various devices are accessing the services thanks to the VO player application through DVB-I mechanism, and whatever their decoding capabilities and their access network. Now, let's first have a look on how IPTV set-top box access the services. So here you will see the user interface of the VO app. We will first select DVB-I, and then the service list will be loaded. We will see that in the service list entry point, 3 service lists are accessible, DVB, SES, and nested. When we go into nested, we will select the declination for our use case here, IPTV, and then the service will start. You will see that VVC is not supported, so the VVC flavor will be skipped to HEVC, and the playback will start for the first channel. We can switch to channel 2, same behavior, VVC not supported on that device, so it switches to HEVC and starts the decoding. So now, let's see how this works on a mobile device. So here you have a 5G capable device. We will start the VO application. Similarly, we will load DVB-I, select the nested component, and go to 5G or LTE service list. The application will open, VVC not supported again, but it will start with HEVC. If we look at the delivered URL, you will see that the local host is actually targeting, meaning that the multicast client on the device is forwarding the stream to the application. And finally, let's see how it works for devices accessing services through a 5G gateway. So here the set-top box is connected to the 5G gateway. Similarly, we load DVB-I, access the nested service list. Yes, loaded the nested service list, and we will access the 5G gateway flavor of the service. Similarly, the service will start with HEVC, and a second, yeah. And if we look at the considered URL, you will see that no, it's not the CDN, it's not the device itself, but it's the URL from the gateway that is accessed to deliver the service. So now, let's conclude this talk. So to summarize, a nested solution provides an high quality of experience, multi-platform and multi-network delivery solution based on DVB technologies. DVB-I, DVB-MIBR, DVB- and DVB-AVC. The nested consortium demonstrates an early implementation of unique features such as DVB-I over 5G, how to interface DVB-MIBR and DVB-I, but also how to interface the 3GPP world and the DVB world, and finally, how to deliver VVC Live services on current delivery infrastructure. So please don't hesitate to visit us this afternoon to further discuss our solution and have access to a more interactive demos than those recorded video clips. Thank you for your attention.
Thank you very much, Thibaut. You've shown a very promising and even sustainable vision of the future of media delivery. So when do you expect this to hit the markets?
So with VVC being standardized by DVB and with the emergence of the DVB CSR, we can expect that kind of solution to be delivered in 2022, I believe.
Thank you very much. We really look forward to this network agnostic distribution of TV. So thanks and see you this afternoon. So now let's move on to our next exhibitor. So I'm now joined by Pedro Valiente e Quezzaretta from Kineton, from Italy, I guess. So good morning, Pedro. We look forward to seeing your demo. Over to you. Sorry, Pedro, you're on mute. Please ensure that your micro is
Sorry.
off.
Okay. Sorry for that. Good morning to everybody. We want to show you today something special. As maybe some of you know, Kineton operates in various industries, and between them, media and automotive. So after building a platform to manage a central service registry that we presented last year in the Dvb Demos, we have decided to keep going that way and to leverage the experience and knowledge we have integrating the DVB-I client in an in-vehicle infotainment system. So as a first thing, we want to show you a video to introduce our solution. So the car you have seen in the video is our Kinecar. It is a full electric and full connected microcar that has been fully designed and developed inside Kineton, including the infotainment system. So we have developed an application dedicated to the infotainment system that integrates a DVB-I client. So gives the user the possibility to watch linear TV directly from their car. So in the next video, we're going to show you the user experience of the DVB-I application. This video has been captured from the 15 inches screen that will be mounted in the Kinecar cockpit. And of course, it allows also the control of some of the car features. So you can, for instance, turn on and turn off the lights or select the lights. Or you can also activate or regulate the air conditioning system by tapping on the arrows or swiping the finger on the screen. But let's show the DVB-I application. By tapping on the icon, you can start the application and the focus will be on the last channel watched. When playing the streaming, as you have seen, the app will take control of the audio and video. It will be then possible to control the volume from the bottom bar or to go full screen by tapping on the indicated icon. Going back to the home page, it's possible to navigate the channel list by tapping on the arrow icons on the bottom bar. Or also you can swipe the finger and select the channel you want. Once you select the channel, the live streaming starts immediately. Another thing we want to show, if for any reason the playback is stopped, once you retrieve the playback, it will start from live. So there's no pause, no buffering, it's only live service. And the channel list shown by the application is loaded from the XML downloaded from the central service registry. So according to the DVB-I specs, the same XML could fill also other devices. So to summarize, sorry, I had problems with it. I want to share the screen to show you some slides on the Kineton. So what we want to summarize is that the Kineton for us, the infotainment system, the Kineton is a device on wheels. It's like as we use the smartphones, as we use the tablets, as we use other connected devices, we will use our cars. So we will get more and more services, more and more applications delivered directly into our infotainment systems. And that's why we deploy this application, because when the car is stopped, when you are recharging the battery, when you are waiting in the car, you will be entertained. Probably many of you know that Tesla has announced that will bring Netflix and Amazon Prime inside Tesla cars. So we decided to bring DVB-I to give a full horizontal TV experience to our users.
Thanks, Pedro, for this really entertaining showcase. And I personally wonder when this overall project is intended to be ready, because I'm looking for an electric car.
Well, the car is ready. The first production sample is ready, and we're going to bring it to IBC in December. So please, everybody, feel free to visit us and to enter the car and to use our infotainment system. At the same time, we look forward for partners in order to start industrial production of the car.
I guess we are all keen to see this happening and to meet you at IBC. So thank you very much, Pedro. And now let's turn to our next participant. I'm now pleased to welcome Laurent Roule from Enhancement. Good morning, Laurent. And like Thibaut, you're based in Rennes, my little hometown in France. So the floor is yours, and see you back very soon.
Good morning, everyone. Thank you, Emily. So we are very glad to participate in this new edition of the DVB Demos. That is the real occasion to showcase all the benefits of DVB internalization. So our today's demonstration is about the delivery of OTT content towards broadcast links. So two years ago, we have wrote a paper in the DVB scene about this delivery over satellite and terrestrial networks. And since then, the DVB has started the specification of this delivery through the DVB native IP specification. And you will see more information in the next video. DVB native IP is a standard under specification based on existing DVB technologies that will be adapted for the requirements of broadcasters that want to leverage IP for the distribution of audiovisual content. Today, linear video over satellite and terrestrial use MPEG transport stream as a transport layer. As with ATSC 3.0, the objective of DVB native IP is to not longer make use of MPEG transport streams for the carriage of video, but to take advantage of more modern technologies such as adaptive bitrate and multicast file transfer mechanism to distribute it. On this basis, DVB native IP aims to reuse OTT streams for the delivery over broadcast networks, rather than having to create broadcast streams for distribution over traditional DVB networks. The specification under the guidance of the TM NIP working group at DVB. 3 subgroups have been identified to cover their requirements. A group dedicated for transports, another for the service signaling, and the last one to cope with content protection. The specifications are planned to be published by end of 2021. DVB native IP targets several business cases addressing B2C and B2B use cases. By delivering OTT content right to the edge, the native IP will allow to optimize and scale the delivery of OTT content at the edge of 5G towers, but also to reach the lowest latency possible for providing the better user experience. DVB native IP will also enable for service continuity. By facilitating the distribution of OTT content to Wi-Fi hotspots, one can watch his or her favorite TV content anywhere at any time. Finally, DVB native IP will pave the way for the unification of audiovisual content delivery by using the same content streams regardless of the network. To illustrate what will bring this new standard, we have prepared an end-to-end demonstration of the delivery of OTT streams via satellite and terrestrial networks, which will constitute a world first and showing the premises of the future standard. The demonstration consists in receiving the live stream from the French DTT network through the DTT caster. The DTT caster receives some of the French DVT multiplexes at its RF inputs and forwards them over IP to an ATEM live encoder. The encoder will adapt the live H.264 streams that then will be distributed to the origin server that will create the different dash segments. The MediaCast broadband will fetch the dash segments from the origin server and will deliver them in multicast using flute as defined in the MABR standard. The SmartGateSat is receiving the OTT content over multicast and encapsulate the IP datagrams into the DVB generic streams as defined in the DVB native IP specs. The signal is transported over DVB-S2 and received by the Neptune that will de-encapsulate the GSC and output the multicast streams carrying the dash segments. In the home gateway runs the CubeAgent broadband that is listening for the multicast streams out of the Neptune. Supporting DVB MABR standard, the CubeAgent receives the multicast streams and stores the dash segments that are available for the device when they want to consume the video. Now we have an end-to-end delivery of the OTT content over satellite. Using the DVT2 broadcasting chain, we are also receiving the OTT streams over the air. So here we are receiving the live terrestrial signal from France in this TV set, and all the broadcast chain, terrestrial or satellite, are delivered through this Ethernet connection to this home gateway, which operates the CubeAgent broadband and deliver the dash segments to all the devices that are available. With the Enhanced OTT at scale, broadcaster and mobile operators have the opportunity to deliver unlimited OTT streams while guaranteeing the best quality of service. So hope that now you know better about DVB native IP. In any case, you can book your slot this afternoon with our colleagues Colin Pryor and Didier Farcy that will allow to answer to your questions, to know more about our solutions, about DVB MABR, DVB satellite solutions or terrestrial solutions, but also targeted advertising. Thank you for your time.
Thank you, Laurent, and that was great. You know, it's a really hot topic at DVB at the moment. So I wonder, are you already speaking with some customers about rolling out this setup?
So indeed, so we are speaking with a lot of customers worldwide in Africa, Asia, and Americas, about customers where actually their mobile data plan is quite high in terms of pricing, and they need to receive over Wi-Fi video when they are out of their home. So this kind of solution is really can help these customers to provide those services. So to provide either live video content over Wi-Fi hotspots for watching the regular video, linear video content, or even for being able to push some file, some data for education, for example.
Thank you very much, Laurent. Those are the use cases we have heard about, indeed. Thank you very much. I'm sure you'll have many people in your room this afternoon. So now let's have a look at what comes next. And I'm now joined by Jan Müller from Dolby in Germany. Good morning, Jan, and over to you.
Hello, my name is Jan Müller. I'm working for Dolby, and I want to show you that DVB-I is the enabler for the next generation of DVB services, including their latest media standards for features like, for example, dialog enhancement. So my presentation contains 2 key points. First, I want to explain and demonstrate you the consumer benefit of dialog enhancement. Second, I want to show you how I have set up a real DVB-I service, including dialog enhancement. So what's dialog enhancement? Dialog enhancement can solve the problem that often in TV program, the dialogue is hard to hear. So this can help consumers, for example, in mobile listening scenarios or for longer viewing time by reducing the listening effort. Dialog enhancement can be added to content when it gets encoded. So this means it basically works for any type of input, even a traditional stereo mix. And within the bitstream, it provides for consumers later on playback side the possibility to adjust the level of dialogue to their own preference. So this is what I want to show you now on my 2 consumer devices from the market that are actually running DVB-I prototype client applications. So many thanks to TP Vision and Sophia Digital for their support with this. So on my tablet device, I want to show you how the user can select for dialog enhancement, and then we will listen into the effect. So let's have a look. This is my tablet running the DVB-I client. Here's the channel list, and TV4 is AC4 content. In the dialog enhancement user interface, the user can select from 3 different levels for the effect, low, mid, and high, and turn it off. I will now turn dialog enhancement on and off while the AC4 content is playing so that you can listen to the effect.
That are there. Their excitement, their reservations, their thoughts as they go through the day.
We're ramped off to like a cliff, so
yeah, totally.
All right, we'll try that one.
Picture's really literal. It's just feeding you information. Sound is much more subtle. It's creating the mood that the picture is feeding you. Adding those layers, it's everything. For me, I edit a lot by feel, and if it feels right, I use it. And I'm sort of insatiable in that respect. I will spend days looking for the right sound effect or the right song. When I won the Dolby Scholarship at Banff, I was really excited. All of a sudden I had access to tools and people with incredible knowledge. Every project I approach now, I now know what it's going to take to make it sound the way I envision it to sound.
On my TV receiver, I have installed the same service list. TV4 is now coming in via the broadcast interface of the TV because this is the preferred service instance. For the broadcast input, I can go to the system menu of the TV, where we'll find a dedicated control for dialog enhancement. Here the user can adjust the preferred level of dialogue compared to the background audio.
A lot of times we have one shot of what we're going to film. One person's going to run a waterfall once. They're going to do this mountain bike jump just once. And I always like to have extra cameras around. If it's just a 1-camera shoot and I'm out there all by myself,
The rendering of the dialogue according to the user setting is actually happening in the AC4 decoder that is built into the device. If you want to try out this prototype application on your own mobile device, please just check in for one of the talking slots later today in the afternoon. So I got really inspired to see how DVB-I can deliver such great user experience. And I must say, I was impressed how quick and easy you can set up a real DVB-I service via the internet. So let me quickly show you what I've done for my demonstration service to show dialog enhancement. So I'm feeding linear AV content with premixed stereo audio into a productized Titan Live encoder. The AC4 encoder inside analyzes this content and encodes additional dialog enhancement metadata into the AC4 bit stream. The output are some dash assets or MPEG-2 transfer stream for my 2 service instances. To make those 2 services discoverable via DVB-I, I have created some DVB-I metadata, so for example a service list, with a very helpful web tool, kindly provided by Sophia Digital. With this service list in the cloud, I can now discover the services on my 2 DVB-I prototype clients, so that we here can listen to the effect of dialog enhancement and also see how the user can adjust the level of dialog in the content. So you have seen a quick setup of a DVB-I service via the internet that provides consumers interactivity with the service to personalize the content experience to their own preference. So I've also shown you how I've set up a DVB-I service, including dialog enhancement, and how I've added dialog enhancement to a traditional stereo mix just by encoding it with one of DVB's latest audio standards, AC4. And I've shown you the real consumer benefit of dialog enhancement on my consumer devices. So I got really excited how DVB-I can open the door and fast-track launches of new services, for example, for testing for the new media standards, or to experiment with these new kind of services for more engagement of the consumers with the service. So that was it for my presentation today. Many thanks for watching, and for now, back to you, Emily.
Thank you very much, Jan, and indeed that's so true what you said. So in brief, if a broadcaster wants to add dialog enhancement or NGA in this way, what should be the next steps for him?
Well, I would just say, try it out. Maybe set up your own DVB-I service via the internet. It's really a reasonable time effort, and make use of those great tools and prototypes, a few examples I've shown in my presentation. And if you want to try out dialog enhancement with your own content, just come around in the afternoon and we will provide you with the right tools to encode your content and listen in and check it out.
So indeed, it seems that people can try this quite easily and see for themselves that DVB-I is a very effective way to deploy those new experiences. So I hope people will take the opportunity to do so and come in numbers this afternoon. Thank you, Jan. So now let's move on to our next demonstration, which is actually the result of the collaborative effort between 4 DVB members. And before the individual speeches from those 4 companies, let's first have a look at the short video that they prepared that gives great insight into the why and the how of DVB's new native IP solution. So Jean-Claude Sachot is with us now in the studio, waiting, I guess. So Jean-Claude Sachot, good morning. So you are the first participant who prepared this end-to-end demonstration. So you're from Broadpeak. And before leaving the floor to you, I know it's a very special day for you. So I would like to thank you very much for your deep and long-lasting involvement in DVB. And we are so grateful that this very special day in your career is dedicated to DVB Demos. Over to you.
Thank you, Emily. Yes, indeed, actually today is the last day of my professional career. I just cannot leave this industry without supporting one last time the Native IP project that I actively contributed to on behalf of Broadpeak for the last 2 years. So this said, let me first start by reminding the audience of what is the vision for Native IP. You've seen this slide already from Laurent, from NNCIS already, but it's important to remind that today video distribution of a broadcast network for linear and live content is very much siloed in its own ecosystem based on MPEG transport stream delivery. However, the thing is that a parallel video distribution ecosystem has emerged and tremendously grown in the past decade, leveraging consumer-owned devices, and that is obviously OTT streaming. The main foundation of OTT streaming is adaptive bitrate streaming protocols. With adaptive bitrate, live video is actually split into small consecutive video files, which are referenced by a manifest. So the video stream can be delivered over any type of distribution network, and not just the internet. The most widely used formats are obviously HLS and Dash. And this is the foundation of Native IP. The good news is actually that broadcast distribution can easily be used to deliver file-based live content. This applies to satellite, which is suitable for distribution of IP payload. Now, the question is, what can Broadpeak and its partners bring to this vision? Well, the expertise of Broadpeak is in the video delivery, supporting content delivery network products and solutions. Broadpeak is also, and this is important here to understand, is also the recognized pioneer of multicast adaptive bitrate streaming. One important thing here is that advanced CDN solutions easily enable valuable services for consumers and content distributors, such as catch-up, cloud recording, content personalization, network monitoring, and so on. So when an operator or content distributor has such an ecosystem in place, it's very easy to offer content that is available anytime, in any place, and for any device. Now back to Native IP. Central to Native IP is multicast adaptive bitrate, and multicast adaptive bitrate using the adaptive bitrate streaming format that I talked about before. But the question is, how do these things map together? This slide is a general representation of a global CDN architecture. All these products are actually software components that run on off-the-shelf servers that are widely deployed in data centers. At a high level, the workflow starts with the video packaging. This is performed by what is called an origin server that is in charge of producing video files. Those video files are actually segments and manifests, as I said before. So complying with the right ABR format, in the case of DVB and Native IP, this is DVB Dash. And then you have a bunch of cache and edge servers that are spread across a delivery infrastructure. As you realize, Native IP leverages several bricks that have already been worked out by DVB, of which DVB Dash, which is a DVB profile defined for Dash for video packaging, DVB MABR, that is IP multicast encapsulation for subsequent distribution over the satellite links, be them broadcast or VSAT actually, and also GSC and DVB S2 and S2X modulations. Now, leveraging the components that are provided by Broadpeak and its partners, what you can see here on this slide is the overall architecture that the group has come up with. And on the right-hand side, a picture of the demo setup that was put together by the partners. This demo setup is running in iDirect's premises. It is worth noting that 2 different satellite distribution paths can be used, namely direct-to-home broadcast, which you see pictured on the top, and VSAT broadband. And this is made possible by the adoption of multicast IP. So the origin packager and the unique cast to multicast transcasters that you see representing on this architecture are actually running on the Dell server that is located at the bottom of the rack. The reverse conversion from multicast to unicast for in-home distribution is performed by a software agent that is integrated in the EKT set-top box that also acts as a redistribution gateway. Before handing over to my demo partners that will provide more insights into this, time has come for me to recap some of the first takeaways of this solution. Firstly, satellite distribution can evolve into an IP distribution channel, and that's a very strong foundation for the native IP solution. This makes it efficient for the delivery of live video content to any type of consumer device, not just the bespoke set-top boxes or smart TVs that have been put on the market so far. And finally, by embracing Dash as their only live video format, content distributors can plan for a unified video distribution platform, regardless of the distribution channel, paving the way for cost-effective hybrid broadcast and broadband media services. So native IP in this regard is the next step for HBB TV, HBB TV being delivered via satellite as well as via other broadcast networks such as terrestrial in future. So this for now concludes my part of the presentation, and over to you, Emily.
Thank you very much, Jean-Claude. And it seems that multicast ABR has been around for quite a few years now, but it was initially targeting IP networks. So now we see that so DVB and ABR also becomes central to this new native IP solution. So how do you see things moving forward?
So, well, actually, maybe as you probably know, market adoption has already begun because Broadpeak is one of the pioneers supplying what I wouldn't call yet a native IP solution, because it's built on the technology that was available, and obviously DVB is gonna package all this in a nice way. But there are already some market deployments that have taken place, typically at Astro in Malaysia. This is already known. Broadpeak has also other deployments for e-education application, typically in Brazil and several other places. Personally, I'm a strong believer of standardization because standardization helps to fuel market adoption by securing interoperability of components. And this is exactly what we are demonstrating here with the partner. It's not just about Broadpeak and its technology. It's about an ecosystem that is already pretty mature. And obviously, market adoption is also enabled by the fact that interoperability drives costs down. So I'm definitely a strong believer in native IP as being standardized in DVB.
As I am, and indeed, interoperability is key, and that's DVB's ground, of course. So thank you very much. Now it's time to move on to our second partner in this multi-vendor demo. So Hans Massart from ST Engineering iDirect. So you're our speaker now. Welcome, Hans, and the floor is yours.
Thank you for the introduction, Emily, and for inviting us to the DVB Demos. Also, thanks to the audience for attending our session of today. My name is Hans Massart, and I'm heading the media and broadcast vertical at ST Engineering iDirect. ST Engineering iDirect is a global leader in satellite communications, and we are active in different markets, as you can see. So it's including media and broadcast, cellular backhaul, trunking, enterprise and broadband, mobility, and government and defense. Our product portfolios are branded under the names of iDirect and NewTek, and you will see that we have embedded those in the demo in the ecosystem of today, the modulator product line as well as the VSAT product lines that we have. And I will be covering our part of the joint demo, native IP over satellite according to the DVB and IP standard, the standardization under effort. And we have developed that, as already said, with Broadpeak, Easy Broadcast, and EKT. Thanks, by the way, for the excellent cooperation over the past couple of months. We can also provide this ecosystem as an integrated solution. So let us take a deeper look now. Here you can see our multi-carrier satellite gateway MCX7000 taking care of encapsulation of the provided multicast ABR video according to MPE in the video stream. Alternatively, also GSC encapsulation can be handled when using our MDM6000 satellite modem. The operator has the choice to deploy DVB-S2 or DVB-S2X modulation. Via the satellite, a range of antennas can receive the content. Here is another view of the Into movie. We discussed already the outbound link, but for those terminals equipped with a VSAT modem, a return channel allows not only to manage applications such as the internet, but also retrieve CDN analytics, handle digital rights management, and more. In this case, the remote site is actually a two-box solution, one for data and one for video, which is often the case. For the technically interested amongst us, here you can see a topology drawing of the ecosystem and where we play. The topology for the bidirectional case looks like this. The box here on the left shows the VSAT hub, which takes care of encapsulation, modulation, and reception from the remote POPs. And aside of the VSAT terminals, the outbound carrier can also be picked up by the EKT set-top box, uniquely handling the GSC decapsulation. This way, depending on the applications that need to be provided to a specific site, a cost-effective set-top box can be deployed or a powerful bidirectional terminal without having to replicate the video content on satellite. Here you can see the setup we have in Sint-Niklaas, Belgium, showing the different components of the ecosystem. In this demo, 2 movies are contributed over satellite to the EKT set-top box, which you can see in the middle between the 2 phones. The large screen shows the first live video, which is received from the set-top box via HDMI. The left phone in the landscape mode shows the second live movie, as you can see screen wide. The phone on the right-hand side in portrait mode shows on top of the live streaming also the metadata, and you can see the Easy Broadcast logo, as that is the app used. The EKT set-top box can either receive the video feed directly from satellite or alternatively from a VSAT modem through an Ethernet connection. Further down, these are dialog VSAT modems, the MDM3310. They provide bidirectional connectivity, so also care for the return channel. These are also dialog VSAT hub components, the M6100 modulator and 2 MCD7000 multi-carrier receivers, setting up the satellite connection bidirectional. Next is the MCX7000 multi-carrier satellite gateway and the MDM6000 satellite modem. And here you can see finally 2 servers. The one at the top carries the Easy Broadcast Management System, and the bottom one carries the Broadpeak components, namely the origin and packager and the transcaster. So what does this now mean for the service provider and the consumer? The consumer is, of course, interested in receiving live and on-demand high-quality content anytime, anywhere, and on any device. And satellite brings many advantages to help achieve this. I've summarized some of them here. It would take us too long to address all of these now, but you're welcome to join us for an afternoon session. And we also can help you with the deployment of the system. Thank you.
Thank you, Hans.
Hi, thank you.
Thank you. So it's really great. Oh, sorry.
No, so I just want to say we will be available this afternoon, of course, for further questions and a continuation of demonstrations.
Yeah, and I'm sure you have many people. So it's really great to see a real end-to-end live system running, and I get that people can also come in your offices in Belgium to see it for real.
Of course, and we also are developing an online version of it.
Oh, so that's the normal way of working, I guess. So I have a question. So DVB's native IP standard is not yet finalized, as we all know. But I also know that your company has been involved already in some of the early deployments that also Jean-Claude just before talked about. So could you please give us some examples of use cases?
So we have this one that Jean-Claude already mentioned at Astro Malaysia, whereby we, in a unidirectional way, address set-top boxes, and then consumers can join additional content on top of what they are enjoying on a screen in a restaurant or another venue. And then there is also another use case for VSAT with Isotropic Networks, one of our partners that is deploying a VSAT network whereby they distribute Netflix content mainly to for maritime applications, so for ships. The return channel here is very important because of the stringent requirements that Netflix has for subscriber management and content protection.
Indeed, thank you very much for sharing this with us. So, and now let's turn to our third participant in this joint demo. So now Jill Mulder from EKT has joined me now from the Netherlands. Good morning, Jill, and we are glad to hear from you.
Good morning, Emily, and it's fantastic to be here. So we are EKT. We are the set-top box company. So at the last end of the demonstration, and over the last few months, we've been working very hard with all the partners to deliver this real life demo. So quite excited about that. So let me quickly show you how it all works and where we are. We put a little video together. Here's our box streaming live to the two mobile phones. We can actually manage up to 3 mobile phones at the same time, and also delivering HDMI at the same time. So for those who do not know who we are, just a quick wrap up. We are a global set-top box company. We have offices around the world. This is also where our customers are around the world. Our main area is in Europe and in the Americas, and where we deliver not only satellite but also a lot of IP products. And I think this is where the native IP over satellite really comes together for us, because we basically combine our two strengths. We call ourselves the East meets West company, which really means that we are very engaged in integration and communication. So our teams here in Europe have collaborated with everybody here to make this product happen. But on the same time, we have a great team in Asia that can also deliver the product in a cost-effective way and with a pretty quick time to market. Just to see where we are in the food chain, so to say. When this signal enters in our remote location in the home, it gets into our set-top box. And this is where we demodulate the signal. This can also be with CAS, so it's also can be with secure signal. Then we de-encapsulate it using either GSE or MPE, so we have both methods built into our box. And then the nano CDN from Broadpeak basically makes it a unidirectional signal. And easy broadcast part is then extracted to make sure that also on the TV the EPG data is shown. So the Easy Broadcast app is then driven by the unicast signal, and on the TV we do this directly with HDMI. So here we see one more time in the total overview. The EKT set-top box feeds the TV and the mobiles, and using a VSAT we can then also stream back relevant information regarding DRM or other data that is required. So we have 2 models. This is our consumer model, so to say. It's driven by a Montage new chipset, 4500D. It's quite powerful, yet still we can make this quite cost effectively. It has a built-in Wi-Fi to stream up to a number of users, but the back also has an Ethernet port, so we can also point this into a router if required. We also have a professional device, which is maybe used for schools or for other places where we can store data, and also then stream it up to a lot more users at the same time. I guess one more important time, because these are the demo days, the live setup of how it all works. And this is live to be seen in the actually the iDirect offices, where we have been able to put this all together and make this a ready to deploy solution. So really just a quick wrap up. We're very happy that we're part of this collaboration. We are able to make it a truly cost-effective and quality product to make it a deployable and ready-to-market solution. Thanks, Emily.
Thank you very much, Gilles. Well, I wonder, you've shown two different types of receivers, a consumer cost-effective ones for homes, and another one targeting more small businesses with the ability to stream to tens or potentially hundreds of devices.
Yeah.
So where do you see the market coming first?
Yeah, so I think actually it's in parallel. So the consumer devices is obviously gives people in remote locations to watch also video on their mobile and tablets. Something that everybody really desires, even if the internet speed is low. But we also get a lot of requests from education, and this is where the professional devices are used in schools, where we can stream up to 200 users at the same time. So then we can really apply it to a lot of more users. We even have use cases where we combine them. So we use the professional device for in school, and then the students get a unit at home to also watch relevant content in their home. So we see really a parallel for both devices.
Okay, so that's two totally different kind of use cases with different goals, but there are some momentum for both. Okay,
Exactly.
Thank you very much. So now I'm curious to listen to the fourth and last partner who contributed to this end-to-end demonstration. So I'm now pleased to welcome Mohsen Haddad from Easy Broadcast in France. Good morning, Mohsen, and by the way, welcome in DVB as a new member. The floor is yours.
Good morning. Thank you, Emily. So my name is Mohsen Haddad, and I am the co-founder and chief revenue officer of Easy Broadcast. We're very happy to contribute to this Dvb Demo Day with our partners, EKT, Broadpeak, and iDirect, where we demonstrate the first end-to-end multi-vendor demo for native IP in a B2C use case. We enjoyed the 2 months or so of collaboration. This demo includes origination, transport, reception, and consumption of live OTT video over satellite. Before going further, I would like to remind you that we are available this afternoon for interactive discussions and Q&As. Please use the meeting planner to reserve your time slot. Easy Broadcast is a French startup created in 2016 based on a patented technology that addresses cost and quality challenges of video delivery. We work with the media and broadcast industry, corporate streaming, and event streaming, and we have a global footprint in terms of clients. We grew to provide turnkey OTT solutions for streaming live and on-demand content. In public or private cloud, these solutions cover end-user applications for smartphones, set-top boxes, and TVs, a backend and CMS to manage content, users, all types of monetization, such as subscription, pay-per-view, purchase, ads, and any mix of these. Based on our patented technology, we also provide the video delivery infrastructure as well as detailed analytics. The analytics include user behavior, quality of service, bandwidth consumption, and monitoring. To address the challenge of providing a full OTT experience in unidirectional and bidirectional networks, we joined our partners in this native IP demo with two components as shown in this high-level architecture. Easy Broadcast technology is deployed both on the head-end side with a CMS and backend, and on the reception side with an edge-cached backend, a gateway, and a fully autonomous smartphone application. First, on the head-end side, our CMS and backend allows to define and manage content and service. This includes editorial animation, user interface templates management, EPG and metadata, user management, access rules, publication management, etc. The service and content definition can be made through a back office and or automated ingest. This will all be transferred through Broadpeak's transcaster and iDirect's modulator. At the reception side, our edge cached service and CMS on EKT set-top box serves as a backend and gateway for the TV UI and mobile application that we prepared. It is deployed on an Android device and shows a full experience. And shows a full experience. This edge cached backend will be connected to the different UIs. So for example, the mobile application will get the example, for example, the list of categories to show on the home screen in different rows and the metadata associated to each content. This way it gets and shows the metadata on live and on-demand videos that has been packaged, sent and received. This metadata includes also the video link to the Nano CDN that will be used to play the video on different devices. Edge caching of service shown in this demo allows a full video experience for end users and the ability to fully manage the service for the customer in a bidirectional as well as unidirectional connected environment, such as delivering education and e-learning for schools in places that are only covered by satellite, or infotainment on a military base, hospital, or boat. We're very happy to contribute to this innovative enablement of live and on-demand content delivery anytime, anywhere, on any device. It allows an improved quality of experience by providing a full content consumption experience regardless of networks and devices, an expanded service footprint and reach, rapid scaling of a service, and cost effectiveness. It is supported by leaders in the industry and ready to deploy. It will be my pleasure answering your questions this afternoon. Thank you. Back to you, Emily.
Thank you very much, Mohsen. And so I see Easy Broadcast is more on the service side of things and perhaps focuses on making things easy. So I'd like to ask you, how easy is it for the users?
So as shown in this demo, it is completely seamless for the end user. They just get their application for the smartphone, and then there's nothing else to do. It's the full experience as you would have on the internet. So you fire up your app, you consume content in a sort of a Netflix-like or a live TV experience. And if you go outside, you will continue to consume on the same app. You don't have to change anything.
Okay, so I look forward to seeing this, even if I shouldn't be able to see anything completely, but for sure this is exactly what the users want. They want more services, more coverage, but with less hassle. Okay, thank you very much. And now I'd like to see the 4 speakers from this multi-vendor demo. I would really like to thank you because it was really a brilliant showcase. And before I let you go, I'd like to ask you, so according to each of you, what's the one big reason why the industry should adopt this DVB's new native IP solution? So first, let's start with Hans, maybe.
Yeah. So from the satellite point of view, we open the door here for OTT business models for the existing video service providers and for all newer entrants to the video delivery scene, such as telcos and ISPs. We provide here a standardized way to transport video efficiently and effectively over broadband networks, such as a VSAT platform.
Okay, thank you very much. Jean-Claude, what's your view?
Yeah, from my perspective, I see very much this as some people call it DTH 2.0. And this is a solution that makes it possible for the operators down the road to switch off legacy MPEG TS. Obviously, that's going to be a long journey because I realize that the weight of the install base is very important. But there are transition plans that make it possible for an operator to introduce that technology for B2C applications and progressively switch off legacy DTH. So that's a real opportunity for convergence of services and cost saving for the operators.
Indeed. Okay, thank you very much. Now, Jill?
Yeah, well, I think from our point is that we're taking the delivery of the signal not to a single screen in the home, but now make it accessible for everybody in the home on their mobile devices and tablets and PCs. So whereby the original traditional satellite was really traditionally what you did on a single TV, I think with what we've now shown is that this is the next era that satellite is actually going into the mobile device.
Indeed. Thank you very much. And now, Mohsen?
I see two main things. The first is with this technology, you are getting education everywhere into the world. This is, at my heart, and I wanted to say it. And next, for the business side, you just use this to get your next billion users of service, thanks to the augmented reach.
Thank you very much. So thanks to all of you for this really efficient collaboration. And I guess you have many people this afternoon in your common room. So now let's have a look at what comes next. So Elfed Howells has joined me from the UK. Hi Elfed, you're also our PCM chair, which is DVB's promotion and communication module. But of course, today you're here as a representative of Huawei. I now give you the floor.
Hi, Emily, and thank you. It's been a great show so far, and I'm looking forward to the other demos as well. I'm going to start with a little video where I'll be talking about how devices are changing. We'll then talk a little bit about internationalization of DVB-I and how it works in different countries, and ending up with a little demo of some of the next generation video coding that we can expect to come from DVB. So the devices we have in our home are really evolving, really changing. They're becoming smarter, better connected, and offer really high quality experiences. This is the Huawei Vision S television. It's a smart screen, it's large format, has all the latest innovations, including video calling and all the innovations in pictures and sounds that you would expect. This is coupled with great connectivity. One thing is different, however. This TV does not have an RF connector. There's a growing market for these kind of devices. Obviously, smartphones, e-books, tablets, and laptops, but now also smart screen televisions. That's why we believe that DVB-I and other similar initiatives to improve and simplify the TV experience for devices both with and without a tuner is crucial. In Spain, for example, where this TV is for sale, there are over 6 local apps that you need in order to stream popular TV channels. And even more apps are needed for international content and multiple VOD providers. DVB-I in the long run can really help us here. It can reduce the complexity of finding our favorite content and really make sure that we have that familiar TV-like experience and EPG even on devices that don't have RF connectivity. In countries where RF is not the main delivery method, making content discoverable is really crucial both for the broadcasters and for the users. The next part of the demo, we'll take a look at how we can make DVB-I international and suitable for all markets around the world. I hand over to Paul Higgs.
Thanks, Albert. Good morning, everybody. From the outset, we knew that internet-delivered television services would not necessarily adhere to the typical broadcast television boundaries. So DVB-I was designed to support the requirements of global markets, as well as provide language independence and multi-language services. As there's no hard dependency on any existing broadcast infrastructure or operational system in order to deploy DVB-I services, it's extremely applicable in greenfield and emerging markets who may have missed out on some of the recent evolution in television systems. As China is looking for an innovative solution to delivering linear television services to a wide variety of terminals and has a comprehensive internet infrastructure and development plan, DVB-I seems like the perfect service information layer once we can break some of the traditional stereotypes regarding DVB and its applicability. In its recent report, CNNIC reported 454 million fiber optic business and residential connections, of which 90% offer 100 megabits per second or higher. And web technologies and DVB-I itself lends itself to providing applications and metadata in different formats through the specification of language tags in HTML pages and in XML documents, all technologies and aspects of these tools that we've exploited. So we started a small internal project to identify how new DVB solutions could be introduced into the Chinese market and integrated with some homegrown technologies. Our first step was to localize the current DVB-I reference client application to offer Chinese language, which required to not provide translations for just a few main screen UI elements, but extend the translation capabilities into about 95% of the UI components. Now it's easy for anybody to add additional translations. And with the UI localization completed, we provided program guide metadata translations for most of the pseudo EPG data made available in the reference solution, along with some small modifications to the application so that a default language could be displayed when a localized translation wasn't provided. And AVS3 now brings a new video codec to DVB, and work is starting there now to include it in the current set of specifications. AVS3 was primarily developed to support 8K media services, and the current activities are focused on live linear broadcasting and on-demand programming. However, all aspects of coded video are possible. This is a premium Chinese streaming service using AVS3 coded video. Here, with a software decoder running on a 2-year-old mobile phone. Of course, all of the typical playback functions are available. Further work with AVS3 along with DVB-I and 5G is continuing, and we hope to be able to bring more innovations at sort of upcoming events. Thank you.
Thank you, Paul. It sounds really promising. So how long would it take to do something similar for another language, for instance, for Russian or for Polish?
Well, I think we've done the lion's share of the work now in the code base to make it easily translatable. The user interface, the application parts itself would be less than a few hours. The metadata, of course, takes a lot longer. It's a lot richer. But I would imagine you would be able to have a localized version of the application running in probably less than a week.
Wow, that's impressive. And probably all that work that you've done in the groups will fasten the rollout of DVB-I. Thank you very much.
You're welcome. Thank you.
So now it's time to go for our next participants. And I'm glad to welcome Thomas Stockhammer from Qualcomm. So Thomas, over to you, and see you back very soon.
Emily, thank you. Yes, good morning, everyone, or in the world, wherever you are, good evening. So we're going to give you a first glance of DVB-I over 5G. And what we're going to focus on is what is MABR over 5G broadcast. That's a specific topic. And that work is jointly done with my colleague Romain and Christophe. They're going to be supporting me in the demo. So the work is jointly with the TEM via access and motion as well. I work for Qualcomm. And so let's move on and enter the show. So just a quick overview, what's happening in DVB? Well, in DVB, we are about to evaluate and have created all of the commercial requirements for DVB-I being a service layer for 5G. And when we talk about 5G right now, we're talking about release 16 that is ready and standardized. And so specifically in this context, there is two technologies. One is LTE-based 5G broadcast, and the other one is 5G media streaming, a unicast technology. And so the attempt is to basically get DVB-I running on top of those two systems to create a TV service over 5G. DVB-I for us includes the codecs, it includes Dash with the low latency and CMF options, MABR, and specifically the root protocol, the service layer metadata, and what we would like to emphasize, the technical work has started in DVB with the specifications, and we expect to have specifications ready by next year. So this is a first glance. And what we're going to have here is we focus on a couple of aspects in this demo. First, what is the feasibility? Can we get DVB-I over 5G live broadcast signal onto 5G mobile device? And then we're looking at a few functionalities beyond the basic broadcast distribution. There's the low latency distribution using low latency dash CMF and root. And the second one is an interesting use case where you basically say, We are operating a broadcast network and a broadcast service. But if you're out of coverage, you do a unicast fallback. The idea of this demo is to be future-proof and be using off-the-shelf tools, commercial phones, stock players, and a lot of the efforts are supported by open source, so you can replicate the demo by yourself. Now I hand to Christoph for kicking off the first demo.
Hello, I'm Christophe Burdiner. Glad to share with you this demo showcasing delivery of DVB-I services leveraging the Rode protocol over LTE-based 5G broadcast. This is achieved with the open source JPAC solution. We will also use a compact mobile network and a set of OnePlus 9 smartphones hosting a Qualcomm chipset. In this demo, a reference live DVB service accessible over the Akamai CDN is ingested by the JPAC route server. This route server produces an IP multicast streams conform to the route profile of DVB-I. This stream is then ingested by our base station and delivered over 5G broadcasts. The streams can now be received by the smartphone and is ready to be decoded and played by the JPAC client. Let's observe this at work. First, by a single command line on the PC, we provide the DVB service entry point, namely the MPD URL and the destination IP address, which triggers the production of the route multicast streams by the JPAC server. And we can immediately observe the 5G broadcast traffic emerging on the monitoring console in red on top. Now that the service is broadcasted within the EMBMS mirror, we take the phones and activate manually the 5G broadcast reception. And opening the JPAC Android app, we just have to provide the route URL, giving the multicast IP address and port to be able to decode. We can now enjoy the video. And here, what you see is the DVB-I service delivered over 5G broadcast using the route profile of DVB-I and leveraging the open source JPAC implementation. And this is it for the feasibility demo, and I'll leave the floor to Roman for the second one.
Thank you, Christophe. Hello, I'm Romain Boucaud from MotionSpell. This second demo relies on the same principles, but it focuses more on the functionalities of DVB-I, especially low latency and hybrid service continuity. We wanted to be able to reuse existing professional players. So in this part, we're using Dash.js and the vAccess Orca player in addition to JPAC. Our goal is to cover some real end-user scenarios, such as a loss of connectivity while being in mobility. So we want to switch back and forth between different sources seamlessly, and this is made possible thanks to a smart gateway that is made of open source tools. So let's go for video. So here we're launching the different tools. So we're going from Dash to multicast route, launching the route receptions and the gateways. On the right, you can see that I'm launching the vAccess Orca player. So on the left, you can see the source. This is a low latency live stream that was provided by Akamai. And on the right, you can see the multicast route, and you can see by yourself that there is zero latency. So to simulate the loss of connectivity, let's kill the broadcast signal. And you can see on the different players that basically you cannot see anything because we switch back to the unicast signal. And if we start again the multicast, then we're going to switch back seamlessly to the multicast. Thank you. Back to you, Thomas.
Yes, Romain and Christophe, thank you very much for support on the demo. As said, there is open source tools available for this one, and we are happy to give you more details in the afternoon, so join us and book a session with us later today. Thank you. Back to Emily.
Well, that's brilliant. But I wonder, why are there two demos actually? And why isn't the gateway embedded in the phone so that we can switch easily?
Yeah, Emily, we wanted to leave some room for the future. So we started and wanted to get first the feasibility with the broadcast signal being done. And I think that was already a major effort to get this in place. The functionalities are that basically we need Android ports for all of these functions. This is under development, but as said, I mean, this is a starting point and not the end, and we're looking forward to participate in more DVB demos in the future, maybe IBC or next year. So we have started this effort. I think there's a lot of opportunities in the future. Thank you.
Yeah, indeed, it's a real preview of the future, and it brilliantly illustrates DVB-I's ability to be network agnostic, amongst other many features. So thank you, Thomas, and thank you to your colleagues also for this world's first demo of a DVB-I service layer running on top of 5G technologies, which is great. So I thank you also. I wanted to thank you also for the great work achieved in the working groups, because Thomas is leading a very important group which make this possible. So we keep rolling on, and now we can welcome our next exhibitor. So Bob Campbell from Eurofins Digital Testing will be joining us very soon. He will be joining from the US, and here you are, Bob. Good morning, and over to you.
Hello, thank you for the introduction and the opportunity to demonstrate two of our test tools for DVB technologies. Targeted advertising is the critical piece for the continued success of broadcast platforms as they seek to keep pace with online streaming. And CR+2's USB form factor and overt watermarking are technologies that will help grow new markets. Compliance and interoperability of receiver devices is the critical foundation to make sure that DVB technologies will work when deployed. And in a moment, my colleague Amy is going to demonstrate an overt watermarking testing demo. But first, here's Aristos to show targeted advertising.
Thank you, Bob. In 2008 and 18, DVB released a set of requirements offering the TA framework for transmitting the adverts. And HBBTV on the other side, they have released the terminal specifications. Ligada suite performs fully automated video and audio analysis to verify receiver compliance to the HBBTV targeted advertising specification. A small introduction about Ligada. It's a PC environment for test case execution. It uses a DVB modulator to play the transport stream on the TV and TCP IP connection to communicate with the TV, the device under test, and to also send the broadband content. Testing for TA, the following hardware is required, such as the webcam, as both the broadcast and the advert video contain QR code giving the timestamps, and an audio capture device for as both the broadcast and the advert contain a continuous tone that encodes the audio timestamps. A Eurofins audio visual data processing unit, in short PDU, is used to acquire and detect timestamp audio and video events to millisecond precision. And this shows how we set up the testing environment for TA in our office. The AV-PDU light sensors are attached on the TV. The webcam is pointing to the TV display. The audio capture comes from the headphone jack of the TV, and RF and Ethernet feeds are in place. You can also see that we use the power line controller for power cycling the TV remotely, and IR controller for sending IR commands to the TV. Both of those tools are fully supported by Ligada. Now I'm going to show you a small demo on how it actually works. On the left side of the screen, you can see the user interface for controlling Ligada, and on the right side, you can see what the TV displays. As you can see, when the user starts the test case, the TV detects the application and starts executing it. And looking at the right bottom of the screen, you will see a white box indicating that the broadcast video is playing. And at this point, we configure the TV to start initiating the switch to the advert. Ligada is capturing the data, which will be used later on to check if the switch has happened at the expected time. As you can see now on the left bottom of the screen, there is a white box indicating that the advert is playing. And on this test case, the analysis is completed successfully, meaning that the switch to the advert has happened at the expected time. Thank you very much. This is the end of my demonstration. And now I'm going to hand it over to my colleague, Amy, who is going to talk about the CI+.
Thank you, Aristos. So I'm going to talk about overt watermarking, which is a new feature defined by DVB. It offers a secure protocol to display a watermark over the video from a scrambled service. And the main purpose is to display subscriber identity over the video. So here we can see the setup. So in the left, we have the host test tool in the PC, which is connected via Ethernet cable to send communications to the cam and to the host. The host will be able to detect the cam in its slot and will be able to descramble the service that's played through the modulator. And the host will wait for signals from the cam for the watermark and will display it. In the bottom here, we also have a list of our automation accessories that are supported by the tool. So here we just have a small demo of it working. So in the top, we have our harness that's running a test case for the watermark. And in the bottom, we have the display of the TV host. So right now, the host is displaying a service, and it's going to wait until it can detect the cam and authenticate. In the top, we have our PC that's configuring the cam and also sending signals to the cam to instruct it to send a watermark instruction to the host. When that host receives that instruction, it shall display in the middle of its screen a green text that will be the watermark. So you see here in the middle. And for this particular test case, we have it where we then instruct the cam to ask the host to remove the watermark afterwards. So the green text in the middle should disappear. As we see there. In other test cases, we would have it where, for instance, the watermark needs to be removed if you change the program or if a menu is shown above. And that's the end of my demonstration. Thank you very much.
Thank you, Amy, and thank you, Aristos. I hope these demos give you a really good understanding of the sophisticated testing that we do to make sure DVB technologies work in the deployments. And please do book a meeting with us later on to learn more. Thank you.
Thank you very much, Bob, and your colleagues. Indeed, CI Plus and targeted advertising also are two areas of interest for many members. And regarding the latter, could you please tell us when this testing tool will become available to implement us?
Sure. The DVB TA specification has obviously been out for a while, but HBB TV has just done the test material in the past couple of releases, and our test tool for that has been in beta form for a while and is now ready for general release to customers, whereas CI Plus overt watermarking is in development and should be later available towards the end of the year or New Year.
Thank you very much, Bob. And indeed, interoperability testing is critical for any deployment.
Absolutely.
So now, last but not least, so it's still about testing, but again, this time back on DVB-I, I'm pleased to welcome our final participants. So I'm now joined by Ranjit Kaur from DTG Testing. Welcome, Ranjit, and the floor is yours.
Thank you, Emily, and good morning, everyone. It is a pleasure to be here today. Today, for the first time, we are demonstrating the DTG DVB-I test suite, which we believe is a critical milestone in industry's journey towards the universal deployment of DVB-I. DTG has been working very closely with the industry to drive advances in media, distribution, and end-user experiences for more than 25 years. Supporting this, DTG Testing, industry's ISO 17025 Quality Assured Test Center, has enabled the seamless market for TV, radio, and IoT. Built on a foundation of excellence in performance, interoperability, and cybersecurity. Supported by DTG Testing test material and testing services for devices, software clients, and applications. And talking to industry, these are the same factors which are critical for the widespread adoption and universal deployment of DVB-I. So building on that track record of deploying the earlier DVB standards, we have created the DTG DVB-I test suite. which will enable the market leaders in DVB-I to have open access to DVB-I devices and applications market to test products and applications are interoperable and they conform to DVB-I standard, to create the market confidence that the DVB-I services and client implementations will interoperate with each other, all helping to create that market confidence for platforms to commit to launch the services to a population of fully interoperable DVB-I compliant receivers, enabling that much needed and called for DVB-I market. So let's take a look at the DTG DVB-I test suite. DTG DVB-I test suite comprises of reliable reference metadata and media stream, a suite of test cases to validate all aspects of DVB-I, a cloud-delivered test management system. Together, this supports the development and validation of DVB-I clients. The test suite aligns with the DVB-I standard for service discovery and program metadata, and it has an established process to support the future versions of the spec. We created this test suite to meet demands from partners and customers to drive interoperability, to support the adoption of DVB-I, and also to encourage the hybrid working. The move towards the hybrid working has enabled the broadcast receiver market to new entrants. So any organization developing or deploying the DVB-I receivers can use this test suite, including TV manufacturers, app developers, and the platform operators. The test suite is built on a fully featured service list registry and metadata manager, which feeds the data to the 6 endpoints of the DVB-I. This can be accessed over the internet by the customers testing or developing the applications, whether this is HBBTV or native applications. We provide media streams, test HBBTV apps, and also the broadcast streams. The whole test suite can be accessed using the test suite portal. It's a cloud-delivered test management system, a complete package for planning, executing, recording, and reporting on the test scripts. The tests are created by DTG using the test manager. This gets loaded onto the test portal, which can be accessed by the user interface of the test portal. We also provide the XML viewer to monitor the request, the metadata viewer, and also the request logger and analyzer to validate and debug all the requests. To perform the test, you start by creating the test plan, fill in all the details of the device under test. Once this is done, you can filter the test cases by the profile of the device and also the area of functionality you would like to test. On selecting a particular test case, you can get the result of all the test information and also the cross-reference to the DVB-I specification. Every step has more in detail information about the action, expected result, and the URL. You can mark the test as not supported if it is not applicable to a test plan. For executing the test cases, you create the test run. Once the test run is created, you come to the same interface for executing these test cases. But at this point, the interface has additional interface to record the test cases, and each and every step can be performed individually. On this particular instance, this is a service list registry test where certain parameters are expected and there is a related URL. On clicking the related URL, you can see the information which is provided by the server so that you can actually cross-check the client implementations. We also provide the logger. This logs all the requests which are made to the server, and if there is any error in the request, this gets flagged to aid the debugging. Coming back to the portal, we also provide the metadata viewer, and metadata viewer provides the convenient way for the testers and the developers to see the metadata. They can drill down into the details of the comprehensive reference metadata which we provide. Coming back to the DVB-I receiver, you can see there are several service list registries and metadata. The suite contains so many service lists to test each and aspect of the specification. This particular test cases has the service list which tests the mechanism of launching the application, the context from which the application has launched. The service has 4 instances, and when you select a particular service, the application gets launched, and this particular application will tell you exactly from where the context, from which context this particular application has been launched. Coming back to the test portal, you can actually create the test reports, and this test reports are the comprehensive test reports which has information about each and every test run. So DVB DTGI test suite provides the metadata for developers to develop and deploy the clients. It has a test suite portal for testing and fault rectification. And together, this provides the essential component for creating a worldwide connected ecosystem based on DVB-I. I had a very limited time to show you very few features of the DVB-I test suite. Please get in touch this afternoon or book a meeting or contact us directly. Thank you, Emily. Off to you.
Thank you very much, Ranjit. So in view of all this work already achieved, I assume that DTG has seen already some momentum. So how much interest do you see in DVB-I?
Well, Emily, the whole industry is watching DVB-I very closely, from the legislators and regulators to the manufacturers, broadcasters, and streamers. At the beginning of this year in the UK, Ofcom consulted DTG to do the technical evaluation of DVB-I for the hybrid delivery. We submitted the report, which is very comprehensive report, including the key findings and the recommendation. And this has been done by doing the detailed engagement with our unique membership. We also commission annual survey, that is the national survey, a state of the nation, with the broadcasters, with the TV industry leaders, as well as the consumers. And this year, 9 out of 10 leaders in the TV industry have named broadcast and IP integration as the greatest area of innovation going forward. In addition to this, DTG testing has also received direct inquiries from a wide range of manufacturers and platforms from different countries who are considering DVB-I as a next generation platform. So it is clear demand is there and we are approaching a tipping end. That's how that is why we launched a brand new test suite as a comprehensive benefit for DTG membership, and also as it enables the industry for the widespread adoption and the universal deployment of DVB-I. Thank you.
Indeed. Thank you very much. And I'm really thrilled to hear so much interest in DVB-I and to see how much progress also has been made in terms of market adoption in the last months. And yes, for sure, this kind of tool that you developed is essential to its success. So thanks, and see you this afternoon. Well, this last contribution from DTG closes this demo series in a very nice way, I think. Wasn't it great what you've seen? This was just 15 members putting together short previews of what they are working on. And that's interesting to see that they are all heading in the same direction. It's all about finding our way in this transition to IP, in this very long journey where hybrid networks are likely to be the norm for long, and where the networks should be used for their own specificities. And that's exactly where DVB-I comes in. As a common service layer that allows any type of service to reach any type of device, regardless of the network. So that could be, for instance, services coming from broadband using DVB- or DVB, so other formats, or even 5G technologies. And this has been, by the way, very nicely illustrated by Qualcomm, that showed an early implementation of DVB-I as a service layer on top of 5G. And they also perfectly illustrated that DVB-I has the ability to switch from multicast to unicast according to the network availability or to the content's popularity. So all sorts of services could come from any kind of broadcast network, which has been demonstrated by the Nested Consortium, that showed that devices with, for instance, a Viaxis Orca DVB-I player could receive services either from terrestrial networks or from broadband. And in this demo, it played some low latency DVB- streams packaged by Atem. So, and finally, DVB-I also allows the discovery of media content that is meant to be delivered over IP networks, but that's actually delivered over broadcast, even if it's using some OTT packaging formats. And this will be made soon available thanks to this new native IP solution that has been showcased today quite extensively by members like Broadpeak, Anansis, ST Engineering Direct, and also our two most recent members, EKT and Easy Broadcast, who, by the way, joined DVB for this purpose, to contribute on this very hot topic. So you've seen that DVB-I allows to leverage any type of network in a seamless way, and this results in many possible benefits. So let me just give you an example from a broadcaster point of view. So, for instance, a broadcaster can progressively enrich its regular offerings. I mean, the legacy services coming from usually from broadcast can be enlarged with, for instance, some services coming from broadband. And thanks to DVB-I, this can be done in a fully transparent manner for the devices because they will discover and then display only the relevant services in a unified interface and above all in a personalized manner because it also takes into account the user's preferences and language, as you have seen from Huawei, who gave an example of a DVB-I player, which was showing some Chinese services and APG. And another very interesting DVB-I player we've seen today also, by the way, was the one from Kineton, from their infotainment system. So this ability to seamlessly integrate any kind of services is exactly what also Dolby and TPV technology told us. Remember, Dolby showed that DVB-I was the quickest means to market new personalized audio experiences, such as dialog enhancement. That could be also the case for any kind of new audio experience. And on their side, also TPV technology demonstrated that DVB-I was enabling hybrid delivery with the best supported quality, depending on the receivers or on the availability of some higher resolutions. So, for instance, you could have UHD coming from broadband. So that's why we can say also that DVB-I is also a powerful tool for IP migrations, because exactly in the same way, you can keep using broadcast for the most popular channels while still starting to use broadband for niche channels or in lower density areas, which makes totally sense when you start a migration to IP. So now you know that the overall DVB-I solution builds on several blocks. For instance, DVB- for the delivery, but also DVB and AVR for the network scalability. But it's also tied with other key solutions like DVB-TA for targeted advertising, which is intended to boost broadcasters' advertising campaigns by increasing the value of their slots, because their ads can now also reach a targeted audience, which is exactly what digital advertising does. So it's likely that the market adoption of such a key thing will be eased, for instance, with the testing tools that you've seen from Eurofins. And probably next year we'll see some more about targeted advertising. But for now, I think that on this matter, a large-scale collaboration is needed, not only from broadcasters, but also manufacturers. They need to congregate around common standards across markets in order to be able to offer predictive experiences to large number of devices. And I think that only standards can help here. So that's why I'm inviting non-members for all parts of the value chain to join the DVB project, because targeted advertising is one small thing, but there is still a lot to be done in many areas. And that's why I'd like to close this session with a brief outline of our current activities. And I know it's enough for me, but I will be very short. So first, worth noting is that there are activities around the extension of targeted advertising for DVB-I. And this will be another important step, by the way, for its market adoption. But you can rather see it in the DVB- activity, since the main impacts are more on the delivery side for DVB-I services. And the key thing to note is that the overall DVB-I suite will be updated to enable DVB-I over 5G technologies, as you've seen today, some demonstrations. And as you can see, also the work on native IP solution has started quite recently, but it's a hot topic, and it has been showcased by 5 members today. And it is expected to be ready by the end of the year. And finally, another very hot topic is around the next generation video codecs. So to make a very long story short, after endorsement this summer of the commercial requirements that are mainly around the delivery of 4K and 8K services, so after that, 3 codecs have been identified as candidates for addition in the DVB toolbox. And then the technical work has started already on DVC, and it will start soon also for AV1 and AVS3. And in parallel, you can see that the second phase of commercial requirements is underway to potentially add some further codecs. So there are a lot which are actually done, and I think that the most interesting should be, so as takeaways, the work on the codecs, native IP solution, and the upcoming updates on the 5G delivery. So I hope that this gave you some insight into DVB's current activities, and especially into our members' main focus, which are creating those tools for tackling the migrations to IP. So please come this afternoon if you'd like to discuss with those companies, and I will be there also, and I'll be glad to answer any questions, as well as my colleagues from the project office, of course, Peter McAvock, our chairman, and Eva McVort, head of the DVB project office. And once again, special thanks to our 15 members who achieved a great job. So thanks not only to our great speakers today, but also to anyone involved in the demos preparation. And my final but great thanks to go to my colleague Owen O'Sullivan, who not only co-organized this event with me, but also produced it. So he's the one behind the scenes, or more precisely just there, who mixed our faces and screens in a so professional way. So thank you very much. Thanks for attending.